Well, welcome everybody to GeoHug, and I'm very excited that we've got Michael de Sousa joining us today. So, Michael is the sales manager of North America for Chrysos Corp, and he'll be chatting to us today about their photon assay technology, the gold standard in mineral analysis. So, this is going to be such a fantastic session. I hope you all enjoy it. Please use the chat. We'll be opening up the floor at the end for some discussions. But yes, thank you so much, Michael, for joining. It's awesome having you here today.
Yeah, thank you so much for the opportunity and having me. I really appreciate it. Thank you.
So welcome. It's great to have you here. We actually, you got some good coverage. I don't know if you saw the other week, but we had Hugh de Sousa on doing a big thing around assaying and the history of, all the different technologies that have come since long time ago. So it's been really interesting hearing about all of this lately. So yeah, it's going to be really good to do a deep dive into it with you. It's going to be
Yeah,
fun.
and I promise there's no relation there between Hugh and I. So we do have the same last name, but I've actually never met him.
You've never met him? Oh, he's amazing.
No.
You'll have to, and he's Canadian, so you'll have to
Yeah, I've heard good things about him.
yeah, definitely. And I was curious what got you into like mining and geology to begin with.
Yeah, so a job. I needed work. Yeah, so I spent,
Fell into
the
it.
better part of my 20s kind of traveling a bit and living somewhat nomadically, teaching English and whatnot. And then after I was teaching English at a private school here in Vancouver for a couple of years, it's a lot of fun, but the money sucks. So I brushed up the resume and I do speak Spanish and Portuguese. And so with that, I got an opportunity doing sales and account management at one company, and then I would say somewhere in the neighborhood of 7 years ago, got into mining and minerals, and I've worked in sales and account management and customer success in the industry since then, and it's been great.
That's awesome. I'm so jealous that you can speak multiple languages. I tried to learn Spanish in lockdown and yeah, it was really hard. I got picked up really fast how to like read Spanish and I could pronounce it really well when I'm reading, but I cannot listen yeah, it's too fast for me. I couldn't pick it up. Very jealous of your skills there.
Yeah, it does take time. I mean, I did live in Mexico for a couple years
Yeah,
at one point, as well as Honduras in Central America. So that was a lot of fun.
that's
And then I
awesome.
got some family and cousins down in Brazil. My dad's actually from Portugal, so
Oh, there you go.
bit of a
So
connection there as well. Yeah. So I
awesome.
helped speak in Portuguese with the grandparents back in the day, up in Kitimat, BC, where they immigrated to, up in the
That
northern part of the province here.
oh, that is awesome. How good. Um,
Yeah.
and I'm curious, so yeah, you've done a bit of traveling and sounds like yeah, been in a couple of different roles. I'm curious what some career highlights are for you so far.
Yeah, so I worked with Sequent. So if there's any resource geologists or modeling geologists on the call here today, they'll likely be familiar with Leapfrog.
Yeah.
So Leapfrog is a product I work with along with the other suite of the Sequent products.
Mhm.
So I was there for a number of years, which was a great experience. I learned a ton and worked with some great people. And then I was at Micromine for almost 2 years. So Micromine, in some respects, was a competitor to Sequent. They have modeling software, and then they also have some other products that focus on the production side. So I worked with a product called PitRam, more as a fleet management system. And I've been at Chrysos now for about a year and a half, and it's been wonderful. They do have a pretty game-changing technology. It's a great company to work for, and I'm really happy here. So it's been nice.
That's brilliant. Well, I can't wait to hear about it all. So thank you for joining us. And yeah, if you want to share your screen, we can get stuck into it.
Great. So thank you everyone for making the time to come on, and thank you to GeoHug and the folks there for having us come on and share some information about PhotonAssay. So I'm the sales manager here in North America. My name is Michael. You got my email there, and I work out of the Vancouver office here, where our main North American office is. Our head office is in Adelaide, Australia. So shout out to all the Australians here today. We do work closely with them, and they come over to our office quite a bit. We've had some folks move here as well, and they're very picky about their coffee. They are coffee folks. Um, I spend most of my time speaking with geologists, metallurgists, but a lot of geology. Yeah, and then depending on what the situation is, could be some mine managers, engineers, and things like that. Okay, so not sure if anybody has seen a photon assay unit or has heard much about it or knows what it is. So I'll start, from the 10,000-foot view here. That image on the right, that's a photon assay unit. So it's the size of about 3 shipping containers stacked back to back. So that's the front end. There's a conveyor belt on the left that's out of view from this image. And then the one on the right, that's actually where they come out of when they're done. So it's an automated unit for the most part. The image on the left bottom, that's the conveyor belt that would be on the left. And you can load up the samples. An operator who would be standing, if you look at that image above, they'd be kind of standing there scanning the barcode, and there's a weigh scale and a fill scale. They place it on the conveyor belt, a robotic arm grabs it, and the rest is fairly automated. And you can see those sample jars. So I'll talk about that shortly, but this is essentially what a unit looks like and what houses the proprietary technology that Chrysos has developed. So a few things to think about. What is photon assay? There's a few different ways we can answer that, but in short, it is a displacement to fire assay. So fire assay being the industry standard in some respects for gold assaying. So photon assay is a new technology that can do it quicker, at a lower cost, and more accurately. And I will explore these as well as I go through the presentation. How does it work? So fire assay is chemistry, right? Photon assay does not use chemistry. It uses physics and X-rays of very high energy to activate gold nuclei. So I'll get a little bit more into the method in a couple of slides down the road, but that's essentially how it works. And it does the same for silver and copper, which are the other 2 elements that we can analyze with the unit. And why it matters. So again, several different answers to this question, but in short, for gold producers and for explorers in the industry, fire assay presents some major challenges. And so photon assay allows you to get your data quicker and drive your decisions. It is more environmentally friendly. It's lower cost. And again, you get those turnaround times much faster with better data quality, more accurate data. I'll dig in here a little bit more on the comparison for fire assay and photon assay. So with those surveys, a couple of the questions were related to who's a chemist, who's a geologist, who's a metallurgist. So I'm assuming that anyone who answered yes to those would be familiar to a certain extent with fire assay, especially these first couple steps here. So, you get your samples, you dry them, you crush them, and then you go through these steps, of which include lead. So you have lead waste, which is something else we'll talk about here. And we got about a 3 to 4 hour window to completion. With photon assay, you're doing the same thing. You're drying the sample and you're crushing it. You can pulverize it, but the vast majority of the time, crushing is sufficient. You place it on the conveyor belt, which we talked about a couple minutes ago, and the rest is automated. So you're dealing with a process that has less opportunity for error because it's more automated. And you're dealing with a larger sample size, which I'll talk about shortly. And you're taking your time from 3 to 4 hours to 2 minutes. On this slide, I'll focus a bit more on the physics and the science behind it. So there is an example of a jar, what we saw in that image from the conveyor belt. Let's assume that we got, 2 to 3 millimeters of crushed material, and there's about 500 grams in that jar. A robotic arm will grab that jar and put it in the activation station. So a linear accelerator hits that sample with 8.5 mega electron volts of energy. So a very high energy source, which essentially causes the gold nuclei or silver or copper, depending on what we're analyzing. The nuclei get excited and they enter an isomer state. That sample is then moved to the detection station. We read the gamma rays that it gives off as it goes back to its ground state, and there's a calculation that gives you your gold grade. The system will integrate with the LIMS system that you're using. So the laboratory information management system that a lab or a mine would use at their on-site lab, and you're getting your results in almost real time. So that's sort of a high-level overview on the physics behind it. Of course, it gets real detailed. It is, after all, nuclear physics, which in a lot of respects is beyond me, but that's the nature of the method there. So as we compare these two methods, there's a few things that we can start to deduce and understand. One thing is the sample size. So the sample size is 500 grams with PhotonAssay, and it goes into that jar. For those familiar with fire assay, the standard size is to use a 30 or a 50 gram aliquot. So if an exploration company is drilling and getting their material assay to determine how much gold is in that sample, let's say that they have a 1 kilogram sample. It'll be crushed, and then 500 grams goes to PhotonAssay. You're looking at 50% of your sample, half of the entire sample, which is much more representative than 30 or 50 grams, which you can see in that other jar as a comparison. So your sample size increases, which lends itself to the data accuracy, which we can talk about shortly. But that's a big thing related to your data quality and your accuracy. I'll touch on these detection limits here. So for gold, the detection limit is 0.01 parts per million, which is equivalent to 10 ppb. You do not need to pulverize the sample. You can use it crushed, 2 to 3. And then that sample weight is usually somewhere between 400 to 650. And getting the grade, it uses the weight in the calculation. As I mentioned, there's an operator who will put the sample on a weigh scale. There's also a fill scale, and it'll use those numbers in the calculation. So there's no hazardous waste. The energy used per sample is less, and you have less opportunity to present error because it's automated. One other note here, it is non-destructive. So that sample goes through the PhotonAssay unit, and you can rerun it over and over again. And you can do the same thing with CRMs. So there's a large saving component as well on the CRM side. So for the geologists who are working in exploration, or perhaps at an operating mine that's looking to expand their resource and they need to report on it through their disclosure documents, press releases, and an updated resource estimate, perhaps. So is this technology certified, accredited, accepted, all those words? So the short answer is absolutely. We have a growing list of hundreds of geologists who've referenced the method in their press releases, in their reports. We have organizations who are using it for their mineral resource estimation model. And then we work with most of the major gold producers nowadays, which I can highlight in a couple more slides. Most of our units are also accredited on the method. So the labs that are operating our units, they can operate for a year and then apply for accreditation. And so most of them have had that accreditation, ISO 17025 standards. I do have another slide that highlights the go-to-market options on how customers can use the technology, which is related to the blue and the yellow dot. So I'll go into that shortly. But this basically gives an overview of where our units are located. The units can be deployed by a commercial laboratory like SGS or ALS or MSA, or it can be deployed directly at a mine site. So the blue dots show direct deployments to mine sites operating gold mines. And the yellow dots are commercial labs that serve producing mines as well as exploration companies that have seasonal drill programs and things like that. This slide is a little bit out of date. We do have 500,000 samples a month. That's closer to about 800,000 samples a month now. We're well over 20 million samples run. And we have some of our key anchor customers here that use the technology, which is not an exhaustive list. We did recently sign a corporate agreement with Newmont, who will be adopting the technology and rolling it out to their sites. And they're currently deploying their first unit at the Ahafo site in Africa, if I'm not mistaken. So here's that slide I referenced about the operating models and how it can be leveraged. So the most basic one that you probably have a sense of is the commercial lab offering the service and taking on multiple customers. So for example, I work in North America and I'm familiar with our partner labs here. MSA has a few labs, Paragon has a couple of labs, and ALS has a unit in Thunder Bay. And so they serve the exploration and the production mines and explorers in the area. They take on a lease with us. We lease the technology. Typically, it's a 5-year lease. And they work with us to get the lease, and then they serve those customers. For those who have worked at mine sites or at labs, likely know that many of these operating mines will contract out their lab service. So you might have an SGS or an ALS or an Intratech contracted the lab work at a site, and the equipment can be owned by the lab. It can be owned by the mine site, and they would get to an agreement. So in short, anyone can own that lease. You can have a mine site owning the lease and contracting the labor out to a lab, or vice versa. And then this third one here, unit leased and operated by miner. So we can definitely lease a unit directly to a miner who has their own on-site lab, who operate it themselves. I will share an example later of Ravenswood, who is one example of these, which is a producing gold mine in Australia. PhotonAssay deals with very powerful energy. So we got 8.5 mega electron volts. Is it safe? Well, not if it's hitting you, but luckily we've designed a system that makes it safe. So the box, we'll call it, has an interlock system. So anytime a door is open, the unit automatically shuts off. There is lead shielding around the linear accelerator, which is the source of that energy, to absorb all of it while that unit is running. The operators all wear dosimeters to measure the radiation, and we've never had an incident where that radiation level has been higher than background levels. These samples also stay in the unit for a cooling period well beyond the half-life. So as an extra precaution for safety, they're held there for an extended period of time before the unit releases them from that other conveyor belt that you can see on the right. So circling back to some of these advantages again, we talked about the costs. So if a unit is leased directly to a mine site, we're very confident that those costs will be lower with the leasing model than what they're currently doing at their on-site fire assay labs. There's minimal consumables. They're fairly simple to operate, so you need less operators. There's more automation. And as we mentioned, you do not need to pulverize the sample. So crushing the sample is sufficient. So you're going to save time and money by only crushing. We talked about the ESG and safety implications. There's no hazardous waste, lower CO2 emissions, and it's a better environment for people to work. We've had a couple of people tell us, yeah, it's a game changer. Fire assay labs are hot, they're dirty, they're ugly, and so they just feel like it's a better experience for them. The data quality. So we talked about how the sample size and less steps involved lead itself to more accurate data. And we have that second dot there that says 1 PhotonAssay measurement equals 7 fire assays. Some of you might have your doubts. I'll show that and how we came up with that number shortly. The method is matrix agnostic, so it's great for all ore bodies, and you can really see more value when you're dealing with coarse gold, nuggety gold, right? Where your fire assay results seem to be all over the place. So it handles all ore body types, regardless of the matrix. I think we discussed the turnaround times, and that's very relevant as you can make decisions in the field. If you're on a drill program, you can optimize that drill program and adjust as you get those results much faster than you would for the traditional fire assay. Process optimization. So again, the samples or the method is non-destructive. So you can take that material and you can do other tests on it. You can run it through the PhotonAssay unit hundreds of times if you like, and store that data, and you have better control over what happens. So we talked about the ESG implications. A quick note on lead. So lead is used, and one of the major challenges with fire assay at labs is that fire assayers, so folks who are working at these labs, routinely get tested for their uh, lead levels in the blood. And employees at labs will typically be on a rotation where they're not doing fire assay too much because of the danger of increasing uh, lead in the blood. So one of the great things about PhotonAssay is it eliminates that completely. So CRMs, there are providers of CRMs directly for PhotonAssay, Aureus, IMS, CDN here in North America as well. And we also have some providers who supply the jars ready to go directly on the unit. Otherwise, you can buy a larger bag and pour it in and get those 500-gram samples. And highlighting again the savings. For anyone familiar with buying and consuming CRMs for fire assay, the costs do add up, especially if you're running, let's say 1 CRM for every 20 samples, which is similar to what a lot of programs run. Those costs drive up. So with these samples, you can run them through the unit again and again, hundreds of times. We do have a wealth of resources showing the confidence of the method, proving it out, case studies, and technical notes. We're happy to share those with anybody interested. We do have our contact information after. I can share this presentation as well. But the point of this slide is to just quickly show, what we've done and some of the examples. One of the documents we have, one of the resources, is what we've done with CRMs and testing it against PhotonAssay. So, it's a fairly thick document, but in a summary, we took 94 CRMs and ran those through PhotonAssay, and you can see the correlation there. Testing it from our lower detection limit of 0.01 up to 10,000 ppm. As we mentioned, it's matrix agnostic, so we did testing on the pulp CRMs for carbon, and we got great results up to 8,000 ppm on that as well. Those are the 4 providers that we went with for those 94 CRMs. We did something similar for silver, slightly less number of total samples or CRMs that we ran. It was 38 from 5 different commercial suppliers. And you can see 2 different detection limits. So why is that? The unit will run a sample of either gold or gold and silver concurrently, so at the same time. And when that is done, if it's a concurrent service, you will need to set the unit for either gold optimized or silver optimized. So if you want to optimize it for silver, you can bring that detection limit a bit lower, right? So you can increase your range. However, if you're not dealing with those low of values and you're okay with a tolerance of something a bit higher, the lower detection limit would be 3.7 ppm on the gold optimized service. In any case, you can see the correlation for the silver analysis against the CRMs. So this is a repeat of that slide of the gold CRMs, but let's take a look at some real world examples. I'll highlight this slide. Earlier, I said that doing one photon assay measurement is like doing 7 fire assay measurements. So where did we get that number? And how do we get to a conclusion like that? So this is a table, and I'll walk through it. I know it's a lot of numbers. But in short, we took material from an ore deposit that we could call moderately heterogeneous. So somewhere in the middle of that spectrum between very homogeneous or very nuggety. And we took 8 samples of a variety of grades from 0.68 more or less to 35 parts per million. So over to the right, you'll see a column that says a single photon assay with a yellow box around it. So the sample was run through a photon assay unit once, and we took that number. So sample 1 was 0.68, sample 2, 0.81, sample 3, 1.22, etc. That was the single photon assay measurement. We then took that same material. So let's say sample 1, we have 500 grams of it. We pulverize it and then fire assay to extinction. And then we record those numbers. So fire assay 1 on sample 1 is 1.3. Fire assay 2 is 0.79. And you can see that these numbers are fairly jumpy. There is definitely some variability in those results. But if you take those 7 fire assay measurements and average them, which is this column over here, the black one, you can see how it lines up very well with the single photon assay measurement. And that's further reflected by the differences that you can see to the right. So photon assay versus fire assay to extinction, the average, and the margin of error there, which is much less than fire assay 1 to its own average. We have run thousands of studies. We've done expansive, robust test work with Barrick, Numa, Agnico Eagle, the list goes on. And 99% of the time, we see a pattern quite similar to this. It'll be less obvious if an ore body is much more homogeneous, for example. You're going to have slightly more consistency with the fire assay, but they could be even more pronounced with something that's completely or strongly heterogeneous. But this pattern of averaging to extinction lines up very well with that one photon assay measurement. Great. So one example I'll highlight of a case study that we've done is the miner who gets their own unit. So they have their own lease and they operate it themselves. They do not hire a third-party lab to fulfill that work. So a little background on Ravenswood. It was acquired in 2020 by a different organization. It's processing now about 175,000 ounces as of 2024. So they've bumped up production. And before photon assay, they had a pulverize and leach system. They also did agua regia, and they sent external fire assays, or they sent samples externally to get fire assayed. So they're dealing with several different methods for their grade control and for their mine samples. And they had some challenges. So they had a backlog. The samples that they ran internally lacked accuracy because we know that pulverize and leach is definitely not as accurate as fire assay even. Then they had samples going externally that would take a long time to get back, and they were trying to make decisions on their operation. So in short, there was a case for them to look at PhotonAssay and how it could impact the operation at their mine. So you'll see this word here, feasibility study. A lot of the larger miners would want to test the method on their own material, which we do. And again, we see patterns very similar to what we showed with fire assay to extinction, as well as this type of a correlation. So taking the numbers that they already have for fire assay and then comparing them to photon assay and running some statistical analysis on that. So they did a couple sets of feasibility studies. This was one, and this was two, which was more robust. So they had a couple of real solid data sets to work with for testing to go ahead and make their decision. They decided to go through and or to go with it and implement photon assay. So what do they need? A building. So this is an image of their site. This is the building that houses the photon assay unit. So it does need to be housed inside of a building, and there is a space requirement for it, as well as reinforced concrete. So that lead shielding that absorbs the radiation from the linear accelerator is extremely heavy. So you do need reinforced concrete. And there is a little bit of an engineering conversation that happens with our deployment team. But in any case, they had that built out, and they have the sample preparation building beside it for drying and crushing. And they were up and running. So we see something similar to this especially for our on-site deployments. They'll do some test work, look at the data against their own rocks. Then we had a contract sign, a unit arrived, and it was commissioned. When this unit arrives, our deployment team goes to the site, whether this is a commercial lab or a mine site. They work with contractors and they stay at site for about a month and a half or 2 months. They build it out and they commission the unit, provide training to the operators, and hand the unit over. And this is what they see. So because they're getting their results in almost real time, we could call it, they're able to make decisions on drilling quicker. They're able to optimize, save money, figure out what they need to send to the mill and what they need to send to waste, depending on their cutoff grades and the mill. As we talked about the enhanced data quality, so you're getting 7 fire assays for every 1 photon assay. The ESG we talked about. And I believe there's a quote here, yeah, from their managing director. If anyone is curious, we did a case study for Ravenswood, and we have a website for it as well as a video that you could watch. And it just kind of is a 6-minute video, I believe, more or less, and it runs through how it's affected their operation, the folks who work at the lab, and how their experience has been extremely positive at Ravenswood. Great. Well, that concludes this portion of the presentation. We got some information there. If you want to jot that down, feel free to contact info@chrisoscorp.com for more information, or reach out to me directly. I did mention a couple things. We do have a wealth of resources. So if you are thinking, Michael, send me the document that you referenced on CRMs, send me something else. We do have resources of case studies, previous test work that we've done. We've done test work on ore samples, summary notes, you name it. We likely have a resource for it. So feel free to reach out.
That's awesome. Thank you so much, Michael.